Good evening, students. Welcome back to Tomoji's Sir class. Today we have taken one problem that already come in JEE mains in physics exam. So today we will try to solve out this problem, and this is a very beautiful problem. Let's first read out the problem. Okay. So what is given? The potential energy function of the force between the two atoms of a diatomic molecule is ux, that is u is the function of x, okay, and it is given as a by x to the power 12 minus b by x to the power 6, where x is the interatomic distance and a and b are constant. Okay, if the dissociation energy of the molecule is u at x to the equal to infinity minus u at equilibrium, then find out d. What is d? D is the dissociation energy, and actually it is given that d, it is equals to u x equals to infinity minus u at equilibrium. Okay, and we have to find out the d, and therefore option is given, and you have to find out this answer. Okay, first you will try to solve out this sum, then I will solve out, then I will make you solve out this problem. Okay, so just pause the video and try to do on your own. Okay. Okay, so I think many of you can solve out this sum, but some of you cannot. But well done that you have tried it at least. Okay, so what is given? So now see, first of all, we will talk about this potential energy function. So what is that? What is given? U is the function of x. Now what is x? X is the interatomic distance. Now what is given here? It is a diatomic molecule. What is diatomic molecule? That means two atom is there, and this two atom is separated by a distance, and this system of two atom is forming a molecule. Okay. Now what is x? X is the interatomic distance. Okay. So this x is the interatomic distance. Now see, when the two atom is there, obviously this two atom has an attraction force as well as there is a repulsive force. Okay, so when two atom is there in a molecule, that means two atom, in between the two atom forces act. Now these forces may be an attraction force, may be a repulsion force. Obviously both type of force can act. Okay, now this thing, this intermolecular force of this intermolecular force, if you go for the higher studies with physics, that means if you do graduation in physics, then in the third year, in a fourth or fifth semester, there is a chapter called in solid state physics. There is a chapter called intermolecular force. Okay, there you will study about the force between the two atoms in a molecule. Clear? Now, when there is a attraction or repulsion force, obviously when the force is acting in between the two atoms, obviously there will be a potential energy function. Now actually, if you see this potential energy function, you will see again this thing you have in the graduation level. And what is the potential energy function? The potential energy function looks like this. What is this? This is the x, and this is u function of x. Again, this is not there in your syllabus. Just for some extra knowledge, I am discussing about this. Clear? This point is the stable equilibrium. This point is the stable equilibrium. That means, suppose this is x0. That means when the two atom is separated by a distance x0, that means that configuration is the most stable configuration of that molecule. Understood? So this is the x0, this is the most stable equilibrium. That means at this point the potential energy is minimum. Now when the potential energy is minimum, That means that point is the most stable, that configuration is the most stable configuration. Understood? So again, this graph, it is not there in your syllabus, just for some extra knowledge I'm giving out this concept. Now we will try to solve this sum. Now how we will do? See, first of all, we have to look at this thing. That means d is equals to u at x equals to infinity minus u at equilibrium. Okay? Now see, again, equilibrium means whenever we are drawing this graph, this point is the equilibrium point, u at equilibrium. This is the u at equilibrium. Okay? This point is u at equilibrium. Now, how we will find? Just wait and watch. Okay? Now see, first of all, we will work out with this thing. That means u at x equals to infinity. That means again, when we are drawing this graph, wait a minute. X, this is ux, this was the function. That means x at infinity means this way. That means infinity means an infinite distance apart, when the two atom is at infinite distance apart. And this is the most equilibrium position. X0. That means the potential energy u at x equals to infinity minus u at equilibrium. This is defined as the dissociation energy. Okay? Now, now how we will do? First we have to calculate u at x equals to infinity. Now how we will do? Let's see. That means the function is given a by x to the power 12 minus b by x to the power 6. Now see, we have to put x equals to infinity. That means a by infinity to the power 12 minus b by infinity to the power 6. That means anything divided by infinity is 0. 0 minus 0. That means 0. So u at x equals to infinity is 0. Okay? Just name it as equation 1. Understood? Now we will proceed further. Now we will try to find out what is u at equilibrium. Now how we will do this? Now see, suppose this is the function. Now this is the u at equilibrium configuration. Now see, we know we have already read a chapter in mathematics, that is maxima and minima. Now see, this is the minima of this function. This is the this point is the minima of this function. Now we know that at the minima point position, if we derivative the function with respect to x, now at the minima position, this derivative will comes out as 0. We know this thing, we know this concept from the mathematics. But those who don't have mathematics in their curriculum, just know it that whenever there is a minima at a function, at that position, that means at x equals to x0, if we put the value at x equals to x0, at that position, the first derivative will come out as 0. Okay? Now what we will do? We know this function. a by x to the power 12 minus b by x to the power 6. Okay. Now what we will do at equilibrium, we put this condition, that means derivative, first derivative at x equals to x0 is equals to 0. Okay. Now what we will do, first derivative means dx of a by x to the power 12 minus b by x to the power 6 equals to 0, turns out as 0. Then what it will come, minus 12 a x to the power minus 13. If we derivative this one, then this will come minus of b into minus 6 x to the power minus 7. This will come out as 0. Okay. This minus and this minus will get plus. So minus 12 a by x to the power 13 plus 6 b by x to the power 7 is equals to 0. Okay. Now what we will get from there, this is at x equals to 0, x equal to x0. Now what we get, 6b by x0 to the power 7 is equals to 12a by x to the power 13, 2 x to the power 6 is equals to 2a by b, we get. Okay. Yes. So x0. So what we get? We get x0 to the power 6 is equals to 2a by b. Just name it as equation 2. Okay. Now what we will get, I'm rubbing out this thing. So what we get, u at equilibrium is equals to a by, now see, it is x to the power 12, now we get x to the power 6 is equals to this much, because u at equilibrium means x0 and x0. Okay. Now what we get, x0 to the power 12, we can write x0 to the power 6 इसका whole square, b by x0 to the power 6 we get. So a by 2a by b इसका whole square, b by 2a by b we get. Now if we do the LCM, 2a by b whole square is the LCM, a minus b into 2a by b we get. So this will get cancelled out, a minus 2a we get, that means what we get, a minus 2a by b so whole square, that means minus a by, now see this is in denominator, in numerator how we can write, b by 2a whole square means 4a square, 1a will get cancelled out, so what we get, minus b by 4a. So what we get, u at equilibrium is equals to minus b by 4a. This is what we get. Now we know u at x equals to infinity, we got it is as 0. And what is u at equilibrium? It is b by 4a minus b by 4a. Okay, just we put these two value here. That means 0 minus of minus b by 4a. That means answer will be b by 4a. So dissociation energy is equals to b by 4a. Okay, sorry, here actually b square will be there. See, one mistake we have done. What was the mistake? The mistake was that we got u at equilibrium was what? A by 2a by b whole square minus b by 2a by b. If we do the LCM, 2a by b whole square, a minus b 2a by b. So we got minus a into b square by 4a square. 1a will get cancelled out, that means minus b square by 4a. So we got u at equilibrium equal to minus b square by 4a. If we put this one, that means minus b square by 4a, the answer will be b square by 4a. So the answer will be D. Okay, I think all of you have understand this thing. If you don't understand, then just repeat the video once or twice. It is a very easy sum. I have given some extra knowledge, that graph, that potential energy distribution graph. Okay, just you don't have this in your syllabus. When you will go for the higher studies in physics, there you will find out this graph, this potential energy distribution. Otherwise, it's a very easy sum. Just use a simple concept of mathematics and you can solve out this sum. Okay, so thank you, goodbye.